How can you handle idempotency challenges with failed API retries? Imagine trying to make a purchase online and your internet drops out just as you hit submit. You hit refresh, but you worry about accidentally paying twice. That's where handling idempotency challenges with failed API retries comes into play. When working with external APIs, especially in backend development, you want to make sure that repeated requests don't cause problems like duplicate charges or multiple record creations. First, you need to understand what idempotency means. It's about making sure that sending the same request multiple times has the same effect as sending it once. This is especially important when network issues cause clients to retry requests. Without proper handling, retries can lead to unintended side effects. One of the most effective ways to manage this is by using unique identifiers called idempotency keys. Clients should generate a unique, consistent key for each request that might be retried. For example, a universally unique identifier or a hash of the request data can serve as this key. When the server receives a request with an idempotency key, it checks if it has already processed that key. If it has, it simply returns the previous response. If not, it processes the request and stores the result linked to that key. This way, even if the client retries, the server knows it's the same request and avoids duplicate actions. Next, servers can implement request deduplication. They keep a record of processed idempotency keys and their responses for a certain period, like 24 hours. When a request with a known key arrives, the server responds with the stored result instead of re-executing the operation. This approach prevents issues like double payments or multiple resource creations. Just remember to set expiration policies for these records so they don't take up too much space over time. Designing idempotent API endpoints is another key step. For example, using HTTP methods like put or delete, which are naturally idempotent, helps. Updating a resource with put multiple times with the same data will always result in the same state. For operations that are not naturally idempotent, like creating new resources with post, combining them with idempotency keys ensures safe retries. Handling partial failures and timeouts is also vital. When a network glitch causes a timeout, the client might retry without knowing if the first request succeeded. By using idempotency keys, the server can recognize repeated requests and respond appropriately, avoiding duplicate effects. This makes client-side retry logic much simpler because clients can keep trying until they get a clear success or failure message. Clear communication in your API documentation is essential. Let clients know how to generate and use idempotency keys and specify which endpoints support them. This reduces misuse and helps developers implement reliable retry strategies. Finally, consider setting a time limit for how long you store processed request identifiers. For example, keep them for 24 hours and then delete old ones. This prevents your storage from filling up with outdated data. A practical example is a payment API. When a customer submits a payment, they include an idempotency key. If the network drops and they retry, the server checks if that payment was already processed. If it was, it simply returns the original confirmation without charging again. This prevents accidental double charges and makes the process smooth for users. By combining unique request identifiers, server-side deduplication, and thoughtful API design, you can make your backend systems resilient to failed retries. This approach keeps your data consistent and your users happy, even when network issues happen.